Hello, wonderful students. I welcome you to Eko Learners Support for WAEC and NECO candidates. Today's topic is going to be very enjoyable and educative. I am your chemistry instructor, Jima Rashid. Are you ready? Come on, let's dive in.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
In today's class, we will be discussing Iupac nomenclature of inorganic compounds. And this is the first part of the topic. All right? Now, the subtopic here is understanding the rules of naming inorganic compounds. If you look at the image on the screen there, you can see that is a naming ceremony, which we call Ikomo. You can see the father, the mother, the baby, and all the well-wishers there. So we are going to also be learning how to name today. Okay? So write the topic in your notes as well as the dates, and let's dive in. Okay? The learning objectives that we have set is that at the end of this lesson, you should be able to apply Iupac nomenclature rules to name inorganic compounds correctly. 2, you should be able to appreciate the importance of a universal naming system in chemistry. 3, you should be able to demonstrate the ability to communicate chemical names accurately in various contexts. I believe that at the end of this lesson, you would have been able to achieve these set objectives. But before we leave the objectives, these are some of the keywords that we need to be able to understand the topic proper. First, Iupac. Iupac stands for International Union of Pure and Applied Chemistry. It is a world body that controls what happens in the field of chemistry. Ions. Ions are atoms that possess charge. We have the cation, which are the positive charged ions, as well as the anion, which are negatively charged ions. And ionic compounds are compounds that are formed as a result of combination between a metal and a non-metal. I want you to write the definition of these key terms down, as they will help you to understand the topic. Now, let's introduce the topic, and I want you to imagine you visiting a pharmacy. What is it that you see on the shelves? Of course, you're right. You see drugs. These drugs on the shelves have chemical names. Have you noticed most of these names are usually very long? Do you know what they mean? Do you even know why these drugs have to have a name? Yes, for identity, to be able to identify them. Otherwise, we'll have cases of drug misuse. All right? So, that tells you the importance of Iupac nomenclature. But before we go into the nomenclature proper, it is always important for you to keep your periodic table handy. So you can pause the video right now and get a copy of your periodic table, because that is going to guide you to be able to name chemical compounds correctly. You should also remember that on your periodic table, okay, the metals are usually to the left. You have the metals to the left, okay, the group 1, the group 2 elements, and of course, to your far right there, you have the non-metals ending at the noble gases. So the transition metals are usually between the group 1 and 2, as well as the other groups. That inorganic compounds can be categorized, and they can be named based on these categories. You have those that are ionic, covalent, and you have the acids. In this video, our focus is only going to be on the ionic. In subsequent videos, we'll look at how do you name covalent compounds, and of course, how do you name polyatomic compounds, including acids. Now, let's start with the binary compound. Okay, in your elementary mathematics, you learn about binary numbers. Did you say binary means 2? You are right. Yes, binary means 2. And so binary compounds are compounds that are consisting of 2 different elements. If you see the picture there, that is a picture of new wedded couple, and you can see the 2 of them becoming 1. That's a binary family, okay, consisting of the husband and the wife. So when you have 2 different elements making up a compound, that is a binary compound. And the binary compounds can be formed either by sharing of electrons. This is what happens with the covalent compounds, or it can be as a result of a transfer of electron from a metal to a non-metal. This is how the ionic compounds are formed. Let's look at some examples of binary compounds. You have a compound formed between sodium and chlorine, which is called sodium chloride. A compound formed between hydrogen and oxygen, that is water. A compound formed between carbon and hydrogen, methane. And there are so many more examples of binary compounds. Now let's get to the naming. How do you name ionic compounds? Like I told you, this video is going to be dedicated to naming ionic compounds. So in naming ionic compounds, the rule is very simple. All you need to do is that you need to name the first element, which is usually the cation. The cation is the metal. So you name the metal, and of course the non-metal is going to have to change its name. If you look at this picture again, you will see that when a man and a woman comes together in marriage, okay, most times the woman has to change her name, okay, to the name of the man. So that means that the woman there is the anion, while the man that is able to retain his name is the what? Is the cation. This is really lovely, isn't it? Okay, so the anion, which is the non-metal in this case, is going to have to change its name, and the name is going to end with the suffix "ide." So you are going to be adding "ide" to the name of the anion. So if, for example, the anion is chlorine, okay, it will become chloride, right? If it is fluorine, it will become what? Fluoride, all right? So what if it is sulfur? You're very correct. It will become sulfide. And this is how the rules are applied. So the ionic compounds are of 2 types. You have the type 1 metal, which are only formed. These are ions that only form 1 type of ion. This is usually what you have with the main group elements. Okay, they have just 1 charge. Okay, we call them type 1. But there are also some metals that we refer to as type 2. These are the transition metals, and this is because they have multiple charges. For example, you can have copper existing as copper 1 in some compounds and copper 2 in other compounds. So these are the 2 classifications, I beg your pardon. Ionic compounds, type 1 metal, type 2 metal, and we will be looking at both in this video. So you can see there the ions that are formed by the various elements, okay, on the periodic table. These are the group 1 element there, okay, and you can see they are univalent, okay. So sodium can only be +1 in any of its compounds. Its valency is fixed, okay. The same for all the elements in group 2, magnesium, calcium, strontium, barium, okay. Aluminium, okay, also has a fixed valency. But when you look at the transition elements, okay, these are where you have the type 2 elements, and that means they have multiple charges. So you can see chromium can be +2, can be +3, manganese can be +2 or +4, okay, copper can be +1 or +2. So we're going to look at what are the modifications that you have to make when it comes to naming these type 2 metals. And you can see the non-metals there, okay, nitrogen forming nitride ion, oxygen, oxide ion, and the likes. The noble gases do not form ion, of course, because they are chemically unreactive. So let's look at the type 1 ionic compounds. How do you name them? Simple. The name of the cation, which is the metal, add it to the name of the anion, okay? But you are now going to modify the name of the non-metal, okay, to accommodate ide. So you are going to be adding ide to the name. An example is this. All right. This is sodium. Sodium is the first element here, Na. Okay. And then the chlorine will then change its name to what? To chloride. And that's why the name here is sodium chloride. Another example is this. So the cation here, let me pick my pen. The cation here is aluminium. Okay. And then the anion is oxygen. So the oxygen is going to be changing its name by adding I to it, and the oxygen becomes oxide. Okay? We have the first interactive practice here. And this can be a bit funny. I'm asking you here, what is the name of this compound? IJKLMNO. What's the name of that compound? What do you say? Is that actually a compound? Have you seen a compound like that before? What do you say? Oh, wow. Yes, I was expecting that to throw you off balance because this is not actually a compound, okay? But the name of that compound is actually water. Yes, it's funny, but the name is water because what we are saying here is from H to O. H to O. So, and that is just H2O, which represents water. How about this one? Okay. Okay, you have barium and you have sodium. Have you seen a compound like this before? Is it even possible to have a compound like this? The answer is no, because these are two metals that are combining together. All right, so I just put this just to cheer you up, you know. So jokingly, you can say that the name of this compound is what? Is banana. Is what? Is banana, because you have two atoms of sodium there. So just to give a funny part to the lesson. So, but let's try and name some ionic compounds proper now. Now, the first one here is NaH. So, what is the cation? The cation is sodium. And what is the anion? The anion is what? Hydrogen. So, the hydrogen will change its name to what? To hydride. So, you have sodium hydride. So, the rule is here just for you to follow through. Name the metal ion. What's the metal ion? Sodium. Then name the non-metal, changing its name by adding I to it. So, this is sodium hydride. You're doing well. Can you attempt the second one? Yes. Calcium oxide. Calcium oxide. The oxygen changes name to what? To oxide. This is what? Aluminium sulfide. Aluminium sulfide, because this is sulfur, and so it changes its name there. How about this? Yes, magnesium iodide. The anion there is iodine, so it changes its name to what? Iodide. All right? So it was very simple to name type 1 metals, isn't it? Just retain the name of the cation and then change the name of the anion by adding I to it. How about naming type 2 ionic compounds? That's where you really have to put a lot of effort, because you need to remember what are the charges of this transition metal. So the rule here is what? Name the cation. So that is still the same rule as the previous one. But here now, you are going to be adding the oxidation number of the transition metal, the type 2 metal. That will be put in Roman numerals and then in parentheses. That will be put in brackets. Plus the base name of the anion, okay, which you are also going to modify by adding height to it. So, for example, iron can form two common ions. Oh, that sounds like a rhyme. Iron can form two common ions. That's a good one. Okay, the first ion is what? Fe2 plus and Fe3 plus. Now, we need to be able to distinguish them. Which one is the chemist actually trying to communicate? So, to distribute them, the Fe2 plus will be named ion 2. Did you hear me? The one that has the Fe2 plus charge will be named ion 2. So you can see the name and then the parentheses with what? Roman numeral to indicate the charge, ion 2, while the Fe3 will be named ion 3. Look at further examples, okay? You have CuCl2, CuCl2, okay? Now, what do you think is going to be the charge of the copper, which is a type 2 metal there? Now, to be able to know that, you will need to use deductive reasoning. And that is because the valency of chlorine here is -1. And there are 2 of it. So you know that a compound has to be neutral. So if there are 2, beg your pardon, if there are 2 chlorine atom here and each one is -1, so that means the chlorine is going to be -2. And in order to make that neutral, the copper has to be what? +2. And this is what? Copper 2 chloride. Another example here is what? Iron 3 oxide. How do we know that this is iron 3? Okay, because before the formation of this compound, the ion there, okay, the ion there must have been the one that owns the 3. When you go back to your study on how chemical formula are formed. So the ion was actually the original owner of the 3 before the compound was formed, while the ion, the oxygen has 2. So after the formation of the compound, and that's why you still have to name that iron 3 oxide. Okay, so the oxidation state of iron there is actually +3. So the rules have been set clear for naming type 2 ionic compounds. Okay, you name the cation, put the charge in parentheses in Roman numeral, and then change the name of the anion. So how does it work? Let's actually try and practice with this. So I'm giving you a few minutes to attempt this, and let me see what you are able to come up with. You're welcome back. So how did you fare in this practice question? So what do you name the first compound as? Okay. If in your answer you said that this is iron 2 chloride, then you are right. Okay. Let me pick my pen. Yes, iron 2 chloride, because the chlorine is -1 and there are 2 of it. So that must have been -2, and that means the ion has to be what? +2. So the name here is what? Iron 2 chloride. Did you get that correctly? Give yourself some cheers. You are a champion. Okay, how about the second one? Okay, very good. Magnesium, yes, that doesn't change its name. Magnesium, and the anion changes its name. Bromine then becomes what? You are correct, bromide. Magnesium bromide. Okay, this is a type 1 metal, so you will not need to indicate the charge in parentheses. How about this? What is the name of the third one? What did you write down there? If your answer says calcium oxide, then you deserve a thumbs up. Well done. Calcium oxide. Calcium oxide. Okay? The fourth one, yes, this is a type 2 metal. Okay, and so you have to indicate the oxidation state there. Now, if you look at what is happening here, the sulfur, oxidation state of sulfur here is -2. And the copper here has to be +2 so that it becomes neutral. But you have 2 atoms of copper here, so this has to be divided by 2, giving us the oxidation state of copper to be what? To be +1. Did you get that? Very good. So this is copper 1 sulfide. Copper 1 sulfide. If you actually got question 4 correctly, wow, you are very good at naming now. Okay, now this is a type 2 metal, manganese. That's not magnesium. Don't make a mistake. Magnesium is Mg. Manganese is Mn. It is very important that you get yourself familiarized with the symbols of element. So the first element there is manganese. Manganese. And then this is what? This is oxygen. This is oxygen. So the oxygen there, okay, is 2. Okay? Is 2. So don't say dioxide. Okay? But that means the oxygen state of oxygen has to be -2 times 2, which will be -4. And that means the manganese has to be +4 because the charge has to be balanced or neutral. So that is manganese, put in brackets, 4 oxide. If you got all 5 correctly, you should give yourself a round of applause. That's wonderful. So let's move on. All right. So there are exceptions to the type 2 rule, and that is these 3 ions, silver, zinc, and cadmium. They have fixed charges. Even though they are transition elements, their charges are fixed. Silver is +1, zinc is +2, cadmium is always +2. So that is an exception to that rule, and you can see their location on the periodic table there. Okay. So let's move to the next one. Now, let's move to our top 5 styled question. I hope you are ready. So I want you to follow through as so write down all the compounds down and let us name them. Let's go now. The first one, okay? All the rules are stated here just for you to follow one by one. And the name of this compound, as you can see from what we have been doing so far, is that chlorine here is -2 because that's -1 times 2. So that's -2. Definitely the ion has to be +2. And that compound is what? Iron 2 chloride. Iron 2 chloride. Did you get that right? Very good. Iron 2 chloride. Let's move very quickly to the next one. What do you name this? MgBr2. What is that? Is this a type 1 or a type 2 metal? Did you say type 1? You are correct. Magnesium is a regular metal. Okay, so that's a type 1. So just name the magnesium as it is unchanged. So that is magnesium. And then the bromine changes its name. That is the newly wedded wife there. Okay, changes its name to what? To bromide. You are going to be adding the I to it. That's very easy, isn't it? Let's move to the third one. Move very quickly to the top one now. Okay, this is the third one. This is also very simple and straightforward. It's simple and straightforward. This is a type 1 metal, and that is what? Calcium. Did you say carbon? No, this is calcium. Carbon is just C. Calcium, and then the oxygen becomes what? Oxide. Calcium oxide. Very, very easy. As easy as ABC. Let's look at the fourth one. Fourth one there. This is a type 2 metal, copper. So this is sulfur. That's -2. That's +2, but there are 2 atoms of it. That's divided by 2. So the copper is going to be what? +1. I think we did this earlier. Copper 1 sulfide. Copper 1 sulfide. Very good. And of course, the last one for today, MnO2. This was also done earlier, manganese 4 oxide. So all the rules are there just for you to follow through. So if you are able to name all of those correctly, I say congratulations to you, and you are now a gold medalist when it comes to Iupac. I thank you very much for your patience to follow through all of the steps, and I'm sure that right now you would be ready to look at some of those compounds you have in your chemistry textbook, and you'll be able to give them a name. I say to you, keep learning chemistry and keep exploring. I'll see you in the next class.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
You have any suggestion, any comments, your feedback are very useful. Use the link that you are seeing on the screen for us to be able to serve you better. Ìgbéga ìpínlẹ̀ Èkó, àjùmọ̀ṣe wa ni. Bye for now.